Hi, greetings from the Mountain Path Academy. This is Professor Abhichandran. This is the second session on series on time series data analysis. Today we will discuss forecasting time series data using decomposition additive model using Excel using center moving average. Now, how are you going to do so? So what is decomposition? So today's discussion, we'll just quickly start with what is a decomposition additive model. Then what are the steps? The first step is moving average. Second step is center moving average. Third step is to actually detrend. So remove the center moving average from the original data. And then we calculate seasonality index by taking the average of the respective periods and subtracting by the average. We'll get the normalized or adjusted seasonality index. Then we remove the seasonal index from the original data, deseasonalized. From the deseasonalized data, we actually use a linear trend. We calculate linear trend by using the simple OLS regression, and we using slope and intercept. And then we forecast the data adding the linear trend plus the seasonality index. Then we will examine the model fitment using the mean absolute error, mean absolute percentage, and the R square. Now, so quickly, what is an additive model? So additive model is nothing but the addition of trend, the components of the time series, trend, seasonality, and cyclical component, and what is called the irregular component. In a data where you have only 3 or 4 years or 5 years, the cyclical component will always go with the trend. So we will not be able to isolate a cyclical component. It's very difficult, but we can definitely get seasonal component. And first, so what is an additive model? So first, what are the steps? First, we calculate the moving average. The moving average simply smoothens the data. That means it reduces the short-term fluctuations from the original data and making the data more or less a kind of a straight line. And then we calculate centered moving average, which further actually, and so the strength smoothens the data. Thereby we will get what is called, it removes what is called the seasonality, and what we get is only the trend and the cyclicality, and maybe the irregular component will all be there. Then so once you subtract the CMA from the original data, so what we get is what is called the detrended data. That means we have removed the trend. From the detrended data, we are going to calculate what is called the seasonal index. Then we will do minor adjustment for while doing the deseasonalized. So then we calculate what is called, subtract the seasonal index from the original data again. So you will get the pure deseasonalized data. So y minus Si. Now from that, actually using that data, we actually use a linear trend by using what is called a simple linear regression. So we calculate slope and intercept and use a linear trend. Finally, we forecast, and for additive model T plus Si, then we calculate what is called whether how far the model is kind of fitted correctly. So we'll calculate the mean absolute error, mean percentage and error, as well as we calculate R square. So this is the thing that with these are steps you are going to do one by one. So you should understand what is a moving average. So moving average is simply taking the average of consecutive and values, then moves one value forward. So that is called so we'll take the average and moves one period forward. And what is the advantage? It smoothens. This technique is a smoothing technique that reduces the short-term fluctuation. So it removes the short-term fluctuation. So thereby only the trend or the cyclical will be there, maybe. But since you are handling short-term data, the cyclicality will be there, will not be there. Now, so this is how we calculate moving average in Excel. Now, what is center moving average? Center moving average is basically we take average of the two adjacent moving average. So once you calculate moving average, then we take the average of the adjacent moving average one step down. So that means where we calculate what is an advantage. Again, it gives a better estimate of the trend and cyclical component. So it removes all the short-term fluctuations. Now, so then what we are going to do, once you calculate CMA in Excel, then we calculate what is called, and the third step, y minus CMA. So that will give you what is called, and so from that data, we calculate seasonality index by taking the average of the respective periods and subtracting for minor adjustment. So we normalize the data. Once you have the seasonalized index, we subtract it from the original data. We get the deseasonalized series. From deseasonalized series, calculate a simple linear kind of a regression, and that is and we use and y as a deseasonalized data and x as the time value. We calculate. Then we use the forecasted trend plus the seasonality index. Then we do the model. So let's quickly go into what is called an Excel. And so we'll go into our Excel model. And so what I got, I have a ready-made data. Since this model, CMA additive model, requires a kind of a constant seasonal fluctuation, which does not have much of variation. So if you really look into the data here, the data I have 4 quarters, 4 year, 16 quarters of data. If you really look at the data and simple graph, you can see that, and it has got a trend. We can add a trend line. We can see that in a slightly upward trend, and also it has got a seasonal fluctuations are more or less constant. So this is required for an additive model. But in real world, the seasonal fluctuations may not be constant. So more or less we will use a multiplicative model. First, let's start with this. First step is to calculate what is called step 1, a 4-point moving average. So what you will do is actually and take the average one step down and take the average of these four quarters. Then we drag it, and the final 2 values are not important because it does not cover all the 4 quarters. Then one step down, we calculate the average of the adjacent moving averages. So we calculate the average as the adjusted moving average. Now, so we got, again we need to clean up this data, and now it covers everything. So now we got the centered moving average. Now subtract the centered moving average from the original data. So we calculate from here. So now we got the what is called y minus CMA. It's called a detrended data. So we detrend the data by subtracting this one. Then the next step is you need to calculate seasonality. Here comes a little tricky. So what you're going to do is create a seasonality index table. Since we are dealing with quarters, so we want a quarterly average. So that we take the quarters here and we calculate adjusted seasonality index for additive model. So first we'll take the average if of these quarters where the data is there, and freeze that, reference that quarter, and take the what is called the detrended data. Again freeze that and subtract that for adjustment and average of the same detrended data. Again freeze that, and so you'll get what is called and the adjusted seasonality index. Now we use this data, either we can copy it on each quarter there, or we can use a simple VLOOKUP function. So VLOOKUP function, and first we calculate what is called and refer the value quarter, and use the VLOOKUP table here, and we want what is called and the second column. We want the second column value number 2 and comma false for accurate. So we have the what is called seasonality index, and we have done it for the entire data. Now we will deseasonalize the data from the original data, and so y minus si. So now, so once we use the deseasonalize, then you can use the deseasonalized data for calculating trend. So how are you going to, and we regress. So we regress using and the deseasonalized data. So deseasonalized data and we regress. So how are you going to use? So we'll calculate the slope and the intercept. So slope is equal to slope of and the deseasonalized data, comma, and this one, the period 1 to 16 for the form. Similarly, and we calculate what is called and intercept. So we calculate the intercept, and so just change that and slope to intercept. So we calculate the intercept. We can also use a slope and intercept by using a simple Linus function. So it's quickly, whenever you saw this is the deseasonalized data, and so we can calculate. We'll get both the internet, and so this is your what is called, and this is your slope and this is your intercept. So we want to have a pure linear trend. So how are you going to, so intercept and plus the slope into, so freeze the slope multiplied by the time. So we'll get the pure linear trend by using, that means intercept plus slope into the time. Now the final step is for additive model, trend plus the seasonality index. The seasonality index is here. Now we got that forecast. Now this is the model fitted value. So now we want to know the error, absolute error. We'll take directly the absolute of, and the original data minus my, what is called, minus my this one. So you calculate the absolute the value. Now we divide the absolute error by the original value to know the percentage of, we calculate mean percentage error. So we can, first we will take the, and so this is the and mean absolute deviation. So we calculate this one, and mean absolute error, we're taking the average. So MAE, and okay. Now similarly we calculate mean absolute error percentage, and we take anything less than 10% is good. Since this data is not a natural data, it's a specifically synthetic data, so you have a very good error percentage, which is 1. When you say MAPI is 1, that means that the error percentage is 1 for the model. That what is my accuracy? Accuracy is 1 minus the error percentage. We can also calculate and the relevance and R squared. So R squared between my original value, comma the fitted value, So we can see that the model is and so that is 99% R squared. That means and it also tells the relevance of the value with the fitted value. Now finally we calculate what is called so we will just copy the original data. So this is your original data, and so we will remove this quarter. So this is your original data. Now so this is your actual data. You can call it as Y. Then you have the linear trend. Then you have the forecast. So finally we got it. Now so the linear trend is here, and this is your linear trend, and this is your forecast. We drag it. So this is your forecast. So now why we are going to do, we are going to just show the graph. Now we can see that, and this is the period, and so we can simply, and just since the data is very accurate, you can see that this is your original data and the forecasted data, the green color. The green is the forecast and the blue is the actual data. Since the model is almost 99% accurate, so it is more or less the forecasted data and the actual data fall in line. This is your red color is your linear data. So this session we have discussed about decomposition of time series model forecasting using additive model. So next session we are going to discuss time series data decomposition using multiplicative model using the same center moving average. So thank you very much for your time.